So on that note, let's just dive in and talk about RESTful API design. And this lecture is going to be mostly conversational, and I'll make some notes, and we might look at a little bit of code and some things on the internet. So our goals are understand the conventions of a RESTful API, know a little bit about the history of REST, and let me refer to my notes here. And cover the major RESTful API design considerations. And I'll talk about what each of these are, but essentially a RESTful API is stateless. We want to use HTTP verbs well to communicate good information, and related to that also HTTP response codes. Caching is actually a big deal with RESTful APIs. And there's a lot of sort of default caching that happens. And then sort of like a bonus is a crazy acronym called HATE-OAS, which is hypertext. And I actually have to Google this because my brain is blanking on me. So let's consult the Oracle. Hypermedia as the engine of application state, which is actually quite cool and not that crazy. And we'll talk about that last, because some of the context here is that in reality, RESTful API design is always a compromise between pragmatism and sort of the design ideals of REST. And in the real world, no one really does it perfectly. And that's actually good software engineering. So real quick, what does this REST acronym stand for? Is anyone familiar? Can someone maybe do a quick Google and tell me?
Is it representational state transfer?
Yeah, exactly. Thank you. And I guess the first E there is capitalized. And I would actually have to, I think, Google that phrase, representational state transfer, and read a little bit more about it to break it down in detail. But there are pieces that we can talk about here. Representation, showing information in different forms, state, application state, especially in a distributed app with a client server architecture, AKA web apps. And then transfer, right? Moving information between the client and the server. So this is not that wild, because this is what we've been doing. We've had a server, we have a browser, we're moving information back and forth between them. What happened was, and let me bring this up is in, let's see, the year 2000, a gentleman getting his PhD in computer science by the name of Roy Thomas Fielding, wrote a dissertation where he came up with this idea. He came up with the idea of REST. And his whole thesis was about how to design this. And this was the year 2000, so it's not that long ago. And obviously the internet had been around before then, and browsers and web servers had been around before then, and HTTP requests had been around before then, and they had verbs like get and post and things like that. And people were doing a lot of this stuff. And I'm sure he is building on other people's research, but his kind of thesis, I think, is the first place where he, like, all this stuff was really laid out as like, let's step back and think about how to do this big picture and come up with a system. And then there's a bunch of cool stuff here around it. So on a practical level, created by Roy Fielding in his PhD thesis. Do I need to read the thesis? No, we do not. Is the thesis readable? Yes, it actually is. I haven't been great at this, but I actually would love to like sit down and read the whole thing. And if you go through this, not every CS PhD thesis is going to be like this. I think this one's actually extremely friendly. And if you're interested, I think it's a super cool thing to read, and you'll understand a lot of the principles here. And just looking here, we already can see a lot of things that we're familiar with. Like we've sort of talked about, you know, you've probably heard Zainab or myself use the word resource to talk about some information that we care about that lives on the server. It could be a CSS file, it could be an image asset, it could be a user model, a resource identifier, well, a URL. We've all sort of seen that. Representation, an HTML document, all this stuff. We don't need to read the thesis. I wanted to share this to point out that, let's see here, architectural views. Like there's a bunch of pieces here, but it's not rocket science. It actually is computer science, but it's not rocket science. And a lot of this is things that we've seen before, just server diagrams with more parts. And like, if you go through here, I don't know if there might be some code in this thesis, but there's not a ton. So if this is actually probably like one of the friendliest theses out there to read. Do most software developers read this thesis? No, they do not. And I think the last important question is, do most REST APIs strictly follow the original vision of REST? And the answer is no. There's a huge amount of pragmatism that comes in. So this is like a protocol. This is an architecture pattern. I shouldn't even say a protocol. It's an architecture pattern. It's a way that we can standardize stuff. It's not tied to any one technology, tool, or library. So the most important concept is the idea of a resource. And I would say a resource is anything on the server that we care about and might need to give to the client. So a JavaScript file is a resource, right? We've all seen, you know, get, index.abcdv blah 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 .js. A CSS file is a resource. An image asset is a resource. And now a user is a great example of a resource. And here's where I think you folks have seen this and where this can really get interesting. And then maybe we have a GET request to get a user by ID, and we have a POST request to create a new user, and maybe we're passing in user information in the body of that POST request. Maybe we want to use a put request, an HTTP request where the verb is put. To update something. And then there's also a delete request. So what's another example of a resource in this vein? And it's going to depend on your application. So there's not really like a wrong answer here.
Are you saying like anything you can describe with a variable because a user's just one form of data?
Right. Well, where does the information about the user live in our application?
Database.
Yeah.
Database.
Yeah. And so this is where, like, what is very common is when we're talking about resources is our data models are examples of resources in a REST API. And that we use RESTful API design for CRUD operations. And you could imagine, maybe for some reason, the user profile picture is stored in a different table in the database, right? But maybe the user model sort of connects those things together. Maybe we even need to store user information across 2 or 3 different tables in the database for a user profile or something like that. However, then from the perspective of our React program, of our client application, there is just a user resource, right? And our React program shouldn't know or shouldn't care about the details of how that user information is stored in the database, or even about like the different models, if we're using, Django ORM that handle that data. So from our client's perspective, like a resource is an abstraction over data that's persistent. It's basically we kind of get to decide, well, what is a user? or for controversial foods, what information should be included with the food. And then the REST API is the interface, the boundary between our client and all of the nitty-gritty details about how information is stored and retrieved server side. And like a good example of a collection of resources might be, let's say we have, maybe we have really active users. Or let's say like starred users or preferred users or something like that. The users who are like using controversial foods all the time. Or like actually a good example might be like, what is it, like the sort of Reddit admins? And you could even imagine maybe well, we probably don't need multiple routes for that. So I just want to check in to see if this makes sense about a collection of resources and what I was talking about like the idea of a resource and how it's this sort of like general concept that we can use. And I also want to check in and see what questions people have.
So with RESTful API, it's more of a how we need to look at it when we're making these things, correct? Like it's good practices to get into for when we're pulling, like when we're making our database or our models, we got to look at the end result here for the REST API and stuff. Or
I think so, yes.
Think about it.
Exactly. And I'm going to go to my favorite tool, Excalidraw. And I think I'll do a quick diagram because that is a great question. And let's see if I can select everything and delete it all. Bear with me one sec, folks. So I think this is a perfect diagram moment. So let's say over here, we've got our database. And let's say in the database, we have a users table. And let's say in the database, we also have a comments table because we're going to have users and comments. And then in our Django program, we have that users model, right? And we'll probably have a comments model. And this isn't like the best diagram, so I apologize. And actually, I'll just put like right here. And then what we have here is, what is it? Psycho PG2, or really Django ORM and Psycho PG2 that are, like those are the libraries that link these two things. And let Django talk to our Postgres database. And the Postgres database talk to Django. So I just want to check in and see if people have questions kind of about this like architecture that I'm mapping out, and if this feels good to folks. And this is a great time to ask questions. And I just want to check in to make sure that there's some like familiarity around what we're seeing here.
So at this stage, we're just pretty much observing how Django and the database.
Yeah, exactly. And I apologize. I need to silence my phone so I don't get distracted by it. And so then over here, like we have all these, let's say like, let's have our routes. And we would have a user ID. To create a user, we would maybe have post user, and you would have to pass a bunch of information in there. Put user, again, you'd pass information in there, and delete user ID. And the same thing for, let's see how good Excalibur is. And the same thing for comments, right? We're going to have, we need a way to get a comment. We need a way to create a comment. And maybe here it needs to look something like this. Because what user is creating this comment? Let's say we're not going to worry about modifying comments, but maybe we want to delete a comment. And I want to check in and see how people feel about these routes, which I think, again, it touches on a lot of things that we've seen already. And so I'm really just introducing some new terms and kind of concepts for stuff we've already been doing. And in particular, I want to check in about this post route that I created and see if this makes sense to folks. Or if people have questions about this. And, you know, in Django, we would, in the urls.py file, we'd create this route, and then we'd also have, you know, view functions as well.
We're also assuming that in like the database that the users table and comments table are attached by a foreign key, right?
Yes, I'm not. Yes, and to be honest, I am not kind of going into that level of detail right now with this, because, but you're absolutely correct. That's how we do it. There might be other ways, and to be honest, just from this sort of like architecture perspective, we don't have to worry about that. But that's exactly what we do. Yeah, I'm just sort of like, I'm kind of stepping a level up because I know that we've seen a lot of these pieces. And this is good practice too, to start being able to think about like your application at different levels of abstraction. Yeah, and you're absolutely right. Like there would be like a foreign key and a primary key, and that's how those would be connected. And the ID property that we're using here is probably going to be that foreign key as well. And I feel like this should all look pretty familiar to people. Can someone explain, for this post request here to create a new comment, why did I create the route like this, where it's /user, and then the user ID, and then the comment?
Somewhere in your comment table, you're going to have a foreign key that points to the user primary key. And
Let's
then
step back a little bit. I apologize to interrupt. Don't even worry about the database tables. Just conceptually think about, without thinking about code or implementation, what's the relationship between a user and a comment?
A user has to be logged in to comment.
Even more simply, like I would say a comment has to belong to someone. Someone's got to make the comment. Right?
The user
Like,
makes a comment.
yeah, a user has to make a comment without worrying about logging in or how we implement it. Like this is sort of where I think it's like modeling the universe a little bit, and where this idea of talking about a resource in a REST API is a little abstract, but also really useful. Because if someone was like, hey, let's go build Reddit, or we wanted to build our own version of Reddit, we would want to think about a lot of this stuff before even starting to worry about how we implement it in Postgres and handling login and authentication and things like that. Like, and I think a user having to have a comment is a great example. I'm trying to think of something else we can throw in here. Like, I think I'll use controversial foods. No, I don't think I'll mix it up too much. I think users and comments is a good start. Yeah, and does everyone kind of feel good about this idea? Like, there is an idea of a user and an idea of a comment, and it makes sense that no matter how we implement it in our program, like a comment probably always has to belong to a user. Yeah, totally. And again, as you folks have probably noticed, it's the same concept from a lot of different perspectives. In a lot of ways, this is not that different from when we were doing object-oriented programming, and we might design like a user class and a comments class. And in fact, that's exactly what kind of is happening with Django ORM and the user model and the comments model. And again, user table and comments table, it's like the same resource, the user or the comment, but we have to store that data in different ways or handle it in different ways depending which part of our program we're working with. So you can think of this like conceptual through line. And let me see if I can draw a diagram here. Oh, I'm so sorry. There we go. I would love to make this thing colored. Let's see how we do. All right. Let's use another oval. You know, Macs are great until they're not. There's clearly some setting here where it's trying to be very smart. And let's make this some sort of red. And I think right here, and I'm just going to draw a line. And I got to scooch over a bit. And over here, we've got our browser. And inside that, we've got, you know, our React program running. We've got, you know, my app. Front end. So we have this idea of a user. And in order to represent and save information about that user in our program, we need to persist that data in the database. We need to have some sort of class or something like that to work with that code server side which for Django, we use the user model. And then we need a way to expose that data to the rest of the world for our front-end program to use. And we do that using the patterns of a REST API to represent state and transfer it. And I know I'm kind of harping on a lot of conceptual stuff. And again, I think the really good news here is that like we've all been doing this and seeing this. Now we can just have a little bit more of a conceptual framework that gives us a structure as our programs start to get bigger. And this is why it's valuable to think about like the idea of a resource, because even for what seems like a relatively simple program where maybe users log in and make comments, as you folks have learned, actually building that thing has a lot of moving parts with the database, setting up foreign and primary keys, and so on and so forth. And what we're starting to think about now with these full stack applications is what is the connection between my front end, my client, and my back end? Like, and it happens through HTTP requests and the URLs we use. And so REST is a pattern that we can use to create this interface. And that's why like a resource is sort of this big, vague term. And I'm glad people like Excalibur. I'm a fan too. I really have to give our evening TA Jorge credit for it. So I want to check in and see what questions people have about this, because there's a couple pieces to sort of the patterns and conventions of how to design a REST API, but we've seen a lot of it. And once you kind of, I think, wrap your head around like the problem that this is solving, then I think a lot of that stuff is relatively straightforward, to be honest. It's stuff with HTTP verbs and HTTP response codes and things like that we're already doing.
Hey,
Awesome.
Adam.
Yeah, absolutely. What's up?
Sorry, quick question. So is it just kind of, are we kind of focused more on like the organization of, I guess when we're looking at it, is it kind of like we're the goal is to pay attention to how things are organized and related to each other in REST design and good REST design, I guess, is that what I guess I'm trying to I feel like I'm close to getting the bigger picture of what we're talking about here. I don't know.
That's a great question. And I think you're right too. It's like that is exactly what we're doing. And I'm gonna add even more to the diagram and even another color. And then I think we'll look at the Pokemon server in a second. Maybe like a nice green. So like, and that's, I think this is honestly the cool part of software engineering and computer science. And like we were talking about ChatGPT this morning, like starting to think about these concepts is where like we really start to grow as software engineers and have even more kind of value to give. It's exactly about how to organize stuff. Because what we've basically been doing is learning all these tools, URLs, HTTP requests, you know, so on and so forth, view functions. Now it's like, all right, here are the tools. I need you to go build a skyscraper. How are we going to build that skyscraper? And the skyscraper that I think is the perfect time to look at is the Pokemon API and looking at its API implementation. And one thing about a skyscraper, and I think this will help too, like I'm going to talk very quickly about versioning. To go back to my example, like for our toy program where we're creating these routes, let's say we have successfully launched our site it's controversial foods. Users can comment. Users can talk about the foods that they find controversial. We have 500,000 users. We need to make a change to our Django code, and we need to change one of these routes. But there are tons of websites that like link to our pages and stuff now. How can we do that without breaking all the other websites that link to this? And maybe someone else in a coding bootcamp wrote a program that uses our controversial foods API. What if, I'm trying to think of a good example here of something that we could change. Let me maybe go to the Excalibur because that's what we've been working on. What if for some reason, and let's see if I can zoom in. Beautiful. What if for some reason we decided, you know what, comment was the wrong name. This needs to be comments with an S. How can we do that without breaking everything? And that's where a lot of these patterns come in. And I think what I'll do, because otherwise this diagram will get a little too messy, is I'll just pop over here and I'll do sort of controversial foods API. And we've got the user and we've got the comments resource. And we had get user by ID, we had post user, we had put user, and we had delete user by ID. And for comments, we had get comment by ID, we had post user ID comment, and I think that was it. So if we had to change this, the answer is right now we're in a little bit of trouble, but I could go ahead and do this. I could just make a whole new route named comments. The challenge can be this can get confusing. And what if we want to write programs to do this stuff? So one convention in terms of how you name URLs, and there's a saying that naming is one of the hardest problems in programming. First of all, let's have all of these routes start with /API, because maybe we need like a home page for a user, and that's not actually an API route that sends back data. And let's give our API a version. And now over here, we can create version 2. What's cool is we could write a program that could understand this stuff. So have we written any code? Have we used the new library? No, all we've decided on is a convention for how we want to name things to help organize things systematically. And this is sort of the convention that the collective software engineering community has decided upon. And so much software and so much of the internet follows these conventions that you want the programs that you write to follow these conventions as well, so that everything plays nicely. And that's where I think looking at the Pokemon API is a good example. Like you can see they do exactly that. Like they have version 2 of their API. And you can see that like berries are a resource, and it's telling us exactly what we're getting back. And let's see what else we have going on. So in Pokemon, I guess there are encounters. Let's see if I can find a good one that touches on some other things. Maybe items. Or maybe location. Pokemon. So this isn't a bad example. It's like, how do we organize this universe of Pokemon? Well, we're going to look for abilities. And there's a ton of information that gets sent back. And part of what gets sent back too is another API endpoint that we can call to get information about that Pokemon. So your question, I'm circling, this was the long road, but to circle back to your question about organizing stuff, some of this is, if we all do stuff in a standard way, we can write programs to help us with this. And we'll talk about that at the end of the REST API lecture. But in a perfect world, like an API would always return like the different URLs that you can use to do stuff. So, and you can see here too, like we get information back about how to get more information about the resource that we care about here. So I know I jumped around a lot, so I just want to check in with folks and to see if that was a little helpful a bit in giving some context of what we're doing and how using this pattern called RESTful API design helps us write programs that play well with other programs on the internet. And what questions do people have? Cool. So the good news is that this is all stuff that we've seen. Stanley, it'd be great to do a demo on REST APIs. The good news is all of you will be writing like a RESTful API for your personal projects and your group projects, and you've kind of been doing it already. There's a great question about SOAP versus REST. I don't know the details of SOAP. Let's see, Simple Object Access Protocol. Without going in detail, in the early to mid 90s, before Roy Fielding's PhD thesis on a RESTful API, software engineers still had this problem to solve. And someone came up with a different way of organizing things, and they called it SOAP. And it kind of used some different technologies. It kind of had some different concepts. I think it's still around in the enterprise world, but it basically lost the battle. I haven't worked with it, and it basically lost the battle. It's kind of like VHS versus Betamax. I mean, and both of those then lost the battle to DVDs, which then lost the battle to streaming. So yeah, the short version is all you really need to know about SOAP is it was an alternative to REST that is pretty different from the RESTful API design pattern. And at least in the open source world, it lost the battle. It's a great thing to read about more, but we're not going to go into depth on it. So I think what I want to do now is, well, first of all, check the chat for comments and then talk a bit more about RESTful API design. Kayla, I saw there was a comment in the chat, and I just wanted to check in if that was a comment or a question.
Oh, I was just trying to see if we could, like, I guess review using like our server side URLs with API on it, with the front end where you don't use API. I don't know how to frame it.
Got it. No, I think I understand. That's a great question. And
Okay.
it does get tricky because I know with React Router, there's a lot of like, there's almost like kind of two different sets of routes. And
Yeah.
I think that touches on a really good point about like going back to, I think, some context for REST API. Like in our server-side program, the routes we write that send data back to the client, meaning JSON, these are usually what we mean when we talk about API routes or REST API or anything like that. In the context of like web applications and stuff, it's usually like routes that we're using, I shouldn't say just to get data. To get or modify data. So like each of these routes that we're talking about here and here, like the example would be, let's do a JS example. And this isn't going to be perfect. I'm going to get this wrong. We might do axios.get API v1 user slash, let's say, it's going to look something like this. And I'm just going to use, I'm not going to use async await because I'm a little more comfortable with the promise approach. And then, maybe we're doing something like, we're then updating our React component state. So in our React app, like these routes that we are creating by following this RESTful API convention, these are the routes that we're going to use in our front end app to get data or to change data. Like we would do a similar thing with a post if we wanted to update a user. Is that a little bit helpful with regards to your question?
Yes, I think I'm also like doing the last assessment that we did kind of helped to put the pieces together for me. I think it's just the routing between the pages, and how do I think it's like the routing between each page. And like sometimes when I would try to like refresh my page, it would say like the page wasn't found.
Yeah.
I don't know, like I'd probably just have to show you what I mean,
Yeah.
because I don't really.
I get exactly what you're saying, because with React and React Router and single page apps, it does get complex. And there's definitely a lot of moving parts there. I think what is helpful to think about for the moment, step back a bit, don't even think about React and think about like the Pokemon API, which I think way back when we were doing stuff with Python before Django, early on, before React and before Django, either with Python or JavaScript, we wrote some programs to like interact with it and get data. And so one of the pluses, actually, you raise a great point, Caleb. One of the pluses of kind of following this pattern of RESTful API design is like we're designing our Django server code so that it doesn't necessarily have to be a React app that gets the data from it. We could write a Python program that talks to it, or a very simple website with some JavaScript on it because you're absolutely right that for a single page app with React, like handling page routing and the different pieces gets quite complex. And actually for the purposes of just thinking about our server side API, we don't have to worry about all that stuff at all. As an example, at a big company, we might be on the backend team and our job is to design this API, but then a completely different team writes the React app, they write the front end. We don't have to know how it works. They have to look at our documentation and see how our API works and make the right HTTP requests and stuff.
Okay. And yeah, it's I don't know, this is kind of sad, but I'm really just now starting to like understand Axios calls and pulling the data, retrieving it, updating it. So it's like I get like the requests on the server side. It's just, I guess it's just the front end that was really confusing me and connecting the pages and not necessarily the connecting to the server side.
Got it. And I think, by the way, there's a lot of stuff going on with Axios and promises. And my guess is there are a lot of folks in the class that are also like continuing to wrap our heads around this. It took me a while to really get used to like the idea of a promise. And that's something that to really kind of feel comfortable with Axios, you have to get comfortable with as well. So that makes sense that this takes a while. And I think that's just part of the process too. Like, and that's okay too, because I think part of what we're learning is sometimes we are going to be using stuff and then like we'll dig into sort of the concepts behind it as we go. And we can also look at some other examples later as well. I think the main thing with the REST API, kind of as we're looking at it this morning, is to think about, all right, what we're talking about today, like we are the backend team for controversial foods and we're writing the Django app. And someone else, the other team, is going to write the React app and the front end. And we're actually not going to do any of that. And we actually don't have to think about that at all as we create our Django app and the API. And that's part of actually what this whole REST thing is about, to jump back to the diagram. And another excellent question that someone had, if we have two separate teams writing this, because Kayla, as you pointed out, like writing a single page app, there's a lot of moving parts with React Router. How do the two teams like make sure that everything works well together? And the answer is they have to have a pattern for that overlap. And the overlap is the routes in our Django app, the URLs, and the way that they're structured and designed. And the RESTful API architecture is there to help us create a pattern so that like someone else could come in and look at this and then write the front end for our controversial foods program. And we're just writing the server program, and then we're going to host it and other people on the internet can use it and stuff. And I think now is, and awesome. I'm glad that was helpful. And those are great questions too. I think that this is one of the big challenges and kind of an exciting moment for the class as we dig into this. And so I think just to kind of continue on, I talked a bit about the idea of a resource. We've talked a bit about verbs and using different verbs, and we've seen this. And we've talked a bit about versioning. And I apologize that my notes are a bit messy. The good news is that the lesson for today actually covers this quite well, but this has been a great conversation. So I think that I hope the lesson is going well. The next big REST API concept that I want to talk about is statelessness. And we've all been using this without knowing it. Essentially, the server does not keep track of things from one HTTP request to the next. A cookie sort of breaks this rule. But the idea is that, like, on every HTTP request, the client has to provide all of the information that the server needs to do stuff. And the context here is, imagine that we are Reddit and we have millions of users, and we need a lot of servers to handle all of those users. If, like, every time a user wanted to look at a comment, like, we had to sort of like track a lot of information for that, that's going to eat up a lot of processing power. So by sort of pushing that responsibility back onto the client, then it lets us scale a bit better. And I know that's a bit abstract, but what we've seen is we've already been doing this with cookies and maybe with authentication tokens, right? Where if I'm logged in, I need to send a cookie with my HTTP request or an authentication token with my HTTP request if I want to do certain things on the server. And this is a great example of where basically the whole software engineering community was like, the RESTful architecture is a great idea. However, we need to be pragmatic, and cookies are actually kind of great. So we're just going to use them because the server stores a little bit of information about a cookie somewhere. So people argue about, is this really RESTful? Is it really stateless? And that's not really important. You know, the main thing is, like, you don't have to maintain a connection, which we haven't really seen in class. And I think SOAP did this, and this was one of the problems. I would have to check. And you've all seen this when you've interacted with third-party APIs and you've had to pass a session token or an authentication token with every request. And another big concept is, and we've seen this already, the way that HTTP verbs connect to sort of like create, read, update, destroy operations. And I'm going to introduce a big word here that I always have to look up. So there's this idea of it, a request being idempotent or idempotence, where it's always doing the same thing. And some examples, and this is a convention we want to follow when building a RESTful API. That's really like server-side work. And a good example of this is a GET request. Every time you make this GET request to get a user, you're always going to get the same thing back, right? If the user got deleted, then you would get something different, I guess. But then if you kept making that request, it would keep getting the same thing back. So the conventions around, and then the other term that we should talk about is, I think, a safe request. And I think the easiest way to kind of walk through this will for me to just put up some examples or write the conventions down, and then we can talk about them. So let's use the example of post, user, name, Alice, email, alice@email.com. So first question is, does it modify server-side state? So does this modify the state of our program server-side in some way?
Potentially,
actually,
I mean, it could just be your user is taken into account in the state, like current user.
That is a great point. That is a great point. Yeah, I think, right, potentially, yes. Usually this creates a new user in the database. And you make an excellent point that, like, if the user already exists, what do we want to do? We don't want to create a duplicate of this user, right? But that depends on how we implement it. Like you could imagine a different post request where maybe it's like adding a new controversial food or something. And I apologize, I'm looking at my notes and we may actually have like a confusion here. Give me 1 sec. Sorry about that. So the convention is a post request is something that might change something server side, and it might do something different depending on like what's already in the database. The GET request should never change server side data. So it should always do the exact same thing. So it's both, it's idempotent and safe. And idempotent is really the big idea here, I think. A put request to say modify an existing user Let's let me put that there and that there. So the convention is, it's not safe because it does modify stuff on the server. It should be idempotent because if we are changing an existing resource like a user, calling this endpoint the same way multiple times will still result in the same thing. And I don't think I phrased that very well. So let me give an example. So let's say this changes the name from Alice to Alice. And let's say for some reason we do this again. We make another HTTP request with the same data. We don't want it to change anything. And delete, I misspelled here. And actually delete is a great example. Where if I'm deleting a user, that's not safe. We're modifying information in our database, server-side state. But if I try to delete the same user 3 times, that shouldn't break anything and it shouldn't do anything different. And and so an example would be our view function for handling delete. We probably have been writing them in a way where if we tried to delete a user that doesn't exist, that's not going to, we might need to handle that error, but it's not going to accidentally mess up the database or anything like that. The last piece of RESTful API design is HTTP response codes. And let me just jump to the Mozilla docs. And we've already seen those a bit. And we've seen when an HTTP response comes back, there's a response code and there's a convention around the different responses. And again, the reason is we want everything to be as standardized as possible so that we can write programs to do as much of this work. So if you make a GET request and the information comes back, we want a 200 response code. If we make a POST request to create a new user, we want a 201 response code. If we make a GET request for something that doesn't exist, then the request didn't fail, but we want to tell the client, hey, nothing is here. And it's really the success response codes, and then these sort of error response codes. Like if you try to log in, but you're not authorized, the server should send back a 401 response code. Payment required is experimental. I think that's what the little beaker means right here. You've all seen the 404, right? So this way we could write a program. It can look at the response code and do something based on the 404. And an example of this is like, I think Google browsers, let's see here, Google prefetch. I had to read about this actually. And let's find a better link. Yeah, so there's all sorts of cool stuff that browsers do. What Google Chrome does, I think by default, is when you go to a web page like this one, the browser makes HTTP GET requests to all these links and gets that data. So then when I click on this, it loads faster because some or all of that data has already been gotten. I don't know exactly how much of that does. There's clearly some sort of HTTP request going on there. But so if you imagine that we're building this browser and we want to build this prefetch behavior, that's where like standardized HTTP response codes are really helpful. Because if we're designing the browser code and we're implementing prefetch and we try to get information from a linked page, and then the page sends back like a 404 saying information not found, that tells us, okay, this doesn't exist. Maybe we want to render that link in a different color so the user knows that that link is dead or something like that. So there's a lot of behavior like that the internet kind of like leverages. Like Google search itself is a great example. Like the way that web search works is there are programs called web crawlers that are just programs that people write that like browse the internet and scrape data, but it depends on kind of like standardized responses for stuff. Which is also why kind of following these standards is good too, to make sure that like people see your website and that it appears well in Google search results and stuff. And I should probably pause here because I feel like I've covered a lot of ground. There's a couple other things to talk about, but I've been kind of jumping around a lot. And so I just want to check in with folks and see what questions people have. And again, the main idea here is these are some conventions for how we're going to create routes and the kind of HTTP response codes we should send back and how we should use HTTP verbs so that like we can kind of follow the pattern that the rest of programs on the internet use. And I think actually a great example to share is let's see, internet standards. Yeah, so the internet, you know, it didn't grow out of thin air. People had to figure out how it would work. And probably the researchers and the PhDs that were doing this, this all happened through like, I guess the 80s. This one is from 1989. You know, it was people coming up with ideas and sharing them and asking for feedback. So there's kind of this convention that's been created of the request for comments, and that defines how the internet should work. And these are like the most official versions of how things should be on the internet, and that all software developers everywhere follow so that all the pieces work together. And just to show an example, like this one, let's see what we have here in this one. If we scroll down a bit, like here's a great example. Like in 1989, someone had to decide like, what are we going to call these computers? Let's call them a host. Here's what it should do. And here's what it should have to do. And so all this stuff, HTTP requests, all of these things comes from these RFC requests for proposals that were sent back and forth, and people would talk about them and add them, and they're adding new ones all the time. And this is like the internet. So it's a fascinating document. Architectural assumptions, like why everything is designed this way. You can read in here and you'll see it. It's extremely in depth, and I'm curious if I can find a slightly more interesting RFC for us to look at. Let's see if we can find a good one. Domain names. That one looks promising. So just to kind of scroll down here. Excuse me. Here we go. Perfect. Like, this is where they decided that domain names will be case insensitive. Back in 1987. This is also where the people involved with this decided that domain names would be separated by dots, like google.com, or in this example here, poneria.edu, so on. And so, like, these are fascinating documents, great to dig into if you're curious. Not necessary, like you don't end up going here for your day-to-day work as a software engineer. But I just wanted to share this to kind of, I think that might be helpful too, because there are some really good questions around what is this for? What is the REST API for? How does this connect to the work I need to do? And what we're starting to step into is there's like a whole community and like structure and system of organization for like how everything on the internet works. But most of it comes down to someone saying, here's how I think it should work. Let's all do it this way. And people saying, great, sounds good. Because otherwise nothing would be able to talk with each other. So I think that's a great stopping point for me to pause and see what questions people have. And for me to take a drink of water.
Adam, would you mind going back to the conventions for delete? I think I missed it.
Absolutely. And I apologize, I was muted there for a second.
Oh,
And I wouldn't worry too much about taking notes, by the way. I should have mentioned that as well, both because my lecture has been a little all over the place, but also because in our curriculum content for today, like we cover this pretty well. And also this is like, if you kind of Google REST API best practices, I bet this is going to be from Stack Overflow, or the Microsoft site is probably a good resource. There are a lot of really good resources around here. This is like a lot. The essence of delete is the delete HTTP verb gets rid of stuff, right? It removes data. And so if you're making an HTTP request with a delete in it, like the assumption is that the server might get rid of stuff. And when we're designing our server-side code, because as you folks have seen, we can also sort of specify like what HTTP verbs our different routes accept. I didn't get to it, but we can do it with Django REST framework, or we were doing it with simply if-then statements before in our Django code. Like if we are going to write a Django program and have it have a RESTful API so that some other coding bootcamp could use our controversial foods API, somewhere in our code, we would need to say like, hey, this route, this view function, it accepts HTTP requests that are post requests with that post request verb. and nothing else. And there's a lot of different ways to do that. Initially, we were doing that, I think, just manually with if-then statements. We can also use Django REST framework to help with that as well. And just to circle back as well to the example from here, it's sort of saying the same thing in different words, where like because a delete request might get rid of something, it's not idempotent. It's not guaranteed to always be the same. Or I'm sorry, this is where it gets so confusing. It's not safe, but it's guaranteed. Like if we try to delete the same user 3 times, it's not going to break anything. Like the effect is that the user is deleted, they're gone, no matter how many times we send this delete request. Idempotency is a little funny. It takes a little while to wrap your head around. The starting point is thinking about, is this going to change stuff on the server or not? And in terms of how all this sort of ties to like how we write our code and do work, really it's more about when we're writing our Django server-side code for our personal project, like should this route and this view function accept a get request or a post request or a delete request or a put request? And by the way, there are all sorts of like HTTP verbs. It's not just like you can have anyone that you want. The most common ones are get, post, put, delete. There are a bunch of others that are used for certain things. Patch, some people like to use, some people don't. And you can come up with your own HTTP request verbs as well. But actually, I will share this link because they make an excellent point here. Kind of what we're talking about with this REST API design stuff is essentially a uniform interface. Like everything should kind of be the same and be simple. And yeah, patch, Kayla, patch is a great example of something that there isn't consensus on in the software engineering community. Some people feel like it's good to use, some people not. It's not super common with REST APIs. And that's a great example too of like, as we grow as software engineers, that's what we spend more of our time thinking about. Like, do I want to worry about like using the patch verb or not? The short answer is you don't need to worry about using it right now. Like it's not going to be a deal breaker. It's really get, post, put, and delete that are the big ones. Yeah, what other questions do people have and what things might be useful for me to review as well?
You'd mentioned that you're able to create your own HTTP verbs, if I heard correctly.
Yeah.
That'd be a super complex process.
I don't think so. I don't actually know. Because an HTTP request, at the end of the day, it's just text that we're sending from the browser to the server. But I have never actually done it. So I have to look through here. You know, I need to be a little careful. And this is where it gets a little tricky because browsers are clearly designed around certain verbs: get, post, put, delete. So it would kind of depend on, and really I should say HTTP method. Oh, Postman's a great example. Like I'm pretty sure we can send an HTTP request with whatever method we want. Let's see here, curl custom HTTP method. And then we would have to write stuff on our server to to handle it. Let's see if I can, I just want to find a good example. Let's try this. So right now I'm in my browser. Curl is a command line tool that makes an HTTP request to whatever URL we give it. In this case, we're getting the Google website, which I think wants www. From looking at those docs, it looks like it's this -x flag that sets the verb. So if I do this, so something different happened, right? And if we see the HTML sent back, it says right here, the request method, my custom verb is inappropriate for the URL. So if we imagine that like we were building the Google search engine using Python and Django for that route, www.google.com, in our view function, we would have some logic saying like, if request method does not equal get, do something. In this case, it like this probably won't work for a post request as well. And in fact, here we see right here, 405 method not allowed. And so that's kind of the cool thing, like the HTTP request, it's all just sort of text at the end of the day. But the real trick is, of course, what do you do with it on the server and what is the rest of the internet doing? In terms of like, should I create my own custom HTTP verbs for our personal projects and group projects? The answer is no, because there won't be a need to. The ones that we have are pretty flexible and cover a lot of ground. In most of the work you'll be doing, that probably won't be something that you need. But if you wanted to, you totally could. And again, all you really have to do is be handling it on the server and decide what you want to do with it.
Yeah, I think that'd be a little bit extra. I was more so just curious.
No, for sure. It's a great question. And honestly, I'm kind of stoked. I don't know if the rest of the classes is stoked, but I was actually stoked to do this and see the HTML come back. And you touch on a really good point, which is that like, there's a lot of layers to what we do, right? If I wanted to use the browser and send a custom HTTP request with a custom verb, or do it from some JavaScript, that gets trickier because we have to start digging into like the libraries and stuff and figuring it out. So there's a lot of layers. What other questions do folks have? Cool. So I would say like a good follow-up is for today, I know we're working on personal projects. I do think this first exercise is very good to do, and it's not a programming exercise. The main thing really is just designing an API for a couple businesses, and you shouldn't even write any code. It should end up looking like the notes that I was writing, essentially. And for example, for this job board, Indeed, thinking about it at a high level, what resources do we need for job posts? Well, there's a job and there's a user and maybe there's a company. And we don't have to get that complicated, but then like, what should we be able to do? A user should be able to post for a job. A user should be able to get information about a job. And if we were to write the Django web server program to power this application, what would our routes look like? What would the URL be? What would the HTTP request method, the verb be? And if you want to, you can think about what the HTTP response code should be. And think about which ones change stuff if you do it more than once and which ones don't. So I think it's really valuable to do that for one or two of these. I don't think you necessarily have to do all three. I think it'll help you think a lot about how you want to organize your personal project as well. And to be honest, this is also kind of like growing to like another level of software engineering where a lot of the work that we do actually isn't about writing code at all. And now we get to think about like some design and stuff, which is actually kind of cool. The other exercise, if you want to tackle it, is to build a to-do list using Django and React. And this is a great project. I know that people have a lot on their plates with personal projects and everyone's going to have different bandwidth. If you want to tackle this, it's a great one to do and to use to implement, like to follow the RESTful API patterns that we have. And I think what you'll find is if you do this, that really we have been doing this all along. All of you have been writing RESTful APIs in your Django code without really realizing it. You know, there are a few pieces here and there where we weren't 100% following the convention, but we've been following the big picture with the URLs and the request methods and response codes and stuff like that. I think what I will probably do is find time, probably not this week, but next week, just to talk a little bit about caching and how that works on the internet, and maybe a little bit of a sort of more sophisticated part of a RESTful API that we didn't get to today. That's kind of cool, but good to know about. And maybe do a little bit review of this as well. So maybe we have like an hour-long afternoon breakout session or something like that next week. But yeah, thank you for being patient and kind of covering this stuff. And I hope that this was useful. And I will take some screenshots and probably do some other stuff to share this to share this image, because I think this is a good one. And thank you all for asking questions and for following along.